So today we are going to solve this problem, squares of sorted array 977. So here's the problem. We are given a sorted array. It may contain negative and positive numbers, and we need to return a new array containing squares of each numbers, and this new array should also be sorted in non-descending order. Like, see, if we have nums of array like this: 7, -3, and 2, 3, 11. So if we squares of this is 7 into 7 is 49, 3 into 3 is 9, 2 into 2 is 4, 3 into 3 is 9, 11 into 11 is 1 to 1. Okay, so squares of this number, and if we sort these squares, first come 4, next 9, 9, 49, and 1 to 1. Okay, see, the largest number can come from the most negative numbers or the most positive numbers. Okay, so instead of squaring everything and then sorting, we can use two pointer at the okay, one at the start and one at the end of the array. Okay, so the idea of two pointer is, so we are going to use two pointer pattern, and the idea of two pointer is we place one pointer at the left, okay, and one pointer at the end. So we compare the squares of both pointers. Okay, we compare the squares of both pointers, and whichever is larger, we place it at the last empty position of the result array. Okay, we place this number last in the our result array and move that pointer inward. So repeat until both pointer meets. Okay, so let's take one example and then we understand clearly. If we have nums is equal to -7, -3, 2, 3, and 11. So we make one result array. Array is equal to size 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this is a result array. See, first we compare -7 is take a square to the negative power of that is 49, and see 11 to the power of 2 is 1 to 1. So largest number is 1 to 1. We place at last index. Okay, we place at last index. Next we move next move right pointer to left. Okay, right hand here, left is here, we move right pointer. Okay, next we compare 49 and 3 to the power 2, and that was 9. So largest number is 49. We place at next empty index from the end. So we place here 49 and we move ref pointer right. Okay, now we move ref pointer. So we compare 2 to the 3 to the power 2, it was 9, and -3 to the power of 2, it was 9. So both equal, we place at next index. Okay, 9. Move any pointer, we say we just move left pointer, we move any pointer. Okay, next, so we compare 3 to the power 2, it was 9, and 2 to the power of 2, it was 4. Largest number is 9. We place at index next index, we place here. Okay, next we move left pointer to right, only that is 2 to the power 2, so it was 4. So it was 4, and left place at the first index. Okay, we left it at the first index. So then that's our sorted square array. Okay, So see, always we remember, always compare end of the array, place the largest square at the back and move pointer that gave the largest square and repeat until the array is fully filled. So this is why you, so see, this way you do not need to sort after squaring. Okay, so it's take big of n time, it's very efficient. So now let's understand. So we know this, and see, next we need variables. Okay, so which variables we need? See, so the problem says you have a sorted array with negative and positive numbers and you need square of all numbers sorted. So first variable, input variable is nums. Okay, your original array. So see, like -4 1 -1 0 3 and 10. So this is where your number comes from. And next is result array. Okay, next is result array, new array of same size as nums. We have created this array. Okay, now we want this array also, result array. So store the square in sorted array. So example, it's look like this: 1 2 3 4 5 1 2 3 4 5, and after processing it's become what, 4 0 0 1 9 16 and last 100. Okay, so next we need two pointers. One pointer is left. So okay, start at the array 0 and track leftmost number, and next pointer is right. Okay, end of the array, n-1, he start from 0 and it's right start from here. Okay, so we track the rightmost number because see, largest number square can come from neither end. Okay, so next we need a fill index. We have to fill the index also. Okay, fill index from last, so fill index one variable. Okay, so we start from last index of array, so result array. Okay, we start from result 9-1 last. So current position in result, where you put the largest square, always move backward as you place squares. Okay, and next we need temporary squares, left squares, because square of number at left pointer, and right square. Okay, because of number at right pointer. So we compare which is bigger, then decide which goes into result and result of fill index. Okay, so see, we, the rule is to update pointer. If left square is greater than right square, put left square in result, move left. Okay, we move left pointer, and else put right square in the result, move right, decrease right. Okay, always do fill index with minus. Okay, after placing a square. No, write down the code. Now we need to write a code. Okay, now we have to write a code. First we create vector int result. We don't create n dot size, which we compare here only. New ms num dot size. Okay, so see what it does: create a new array result of the same size of nums. Okay, to store sorted squares. So we need this array because we cannot override the original nums, and we want to sorted squares. Okay, next we initialize the pointers. Int left is equal left start from 0, and int right start from nums dot size, it start from last, and we have to fill the index also. Fill index is equal to fill the index from last, okay, from the end, negative. Next, see what it does. Left points to the first element of nums. Wait, left points to the first element of nums and right points last element of the nums, okay. And this fill index current position in result to place the largest square, like this. Wait a minute. Left is equal to 0. Left is equal to 0. Start from nums of left, that was -4, and right is 4. End of array. Nums of right, it was 10, and fill index for last index in the result, okay. So we need left and right to compare ends, then fill index to fill largest square from end. Next we start loop. We have to start loop also. So the condition is while left is less than or equal to right, okay. So what is the repeat step until left pointer passes the right pointer. This ensure all elements are processed, okay, like this. See, if left is equal to 0 and right is equal to 4, loop runs, and later when left become 5 and right become 4, loop stop, okay. So we need this loop to process every element one by one. Next we have to calculate the square also, na? So see how we take this we have, where is the okay, temporary variables left square and right square. Now we write int left square equal to nums of left into nums of left, and int right square is equal to nums of right into nums of right. So see, find the square of wait, let's see if we write, then we will get them. See, find the square of leftmost and rightmost element if we have nums like this: -4, -1, 0, 3 and 10. So left square be -4 into 16 and right square be 10 to the power and 100. So we calculate square to compare which is the biggest, okay, placing the result. Okay, see, we calculate squares to compare which is bigger for placing in result, okay. Now we compare squares and fill result. See, if we compare, how can compare left square? We compare left square and right square, okay. So we place larger square to fill index. To move the left pointer, we left press or right minus minus, which gave the larger square. So see, if left square is 16 and right square is 100, so larger is 100. So we place 100 at the fill index at 4, okay, index of 4 last. So if we have result where fill index result like this, how we are going to fill 1 2 3, how many number, 1 2 3 0 1 2 3 and 4, okay. So we fill here 100. So we move right pointer left, we move right pointer left, so right becomes 3, okay. Next step is left square is 16. If left square is 16 and right square is 3 and it was 9, So the largest number is 16, so we move 16 at the field index 3, so we fill index 3. Okay, next we move left pointer, left become 1, so we need this if else because we always place the largest square in the correct position. Okay, so let's write down. If left square is greater than right square, RESULT result of field index is equal to left square. Okay, left plus plus else RESULT result of is equal to right square, right minus minus. Okay, so see, we need to fill index minus minus, so after placing a square move one position left in result, prepare for next largest square. Okay, for example, say after placing 100 we fill next is 3, after placing 16 we have to place fill index 2. Okay, we have to fill this index 2 also. Without fill index we could not know where to place the next square. Okay, so that's it. Now we have to do this also. Fill index minus minus and just return the result. RESULT result. Okay, see, and that's it for the sorted square problem. Super simple once you understand the two pointer approach. Okay, try it on your own with some examples and see how it works. Okay, that's it.